When I first asked for suggestions of some topics I should cover for some of these videos, one that I got several times was, can you demonstrate some of the features in the newer standards that allow Fortran to interoperate with C? So in this video, what I'm going to demonstrate is some of the basics of how you can get Fortran and C to talk to each other. So let's dive in and we'll take a look at a bunch of examples, and I'll show you how all this stuff works. At the time I'm recording this, the Fortran Package Manager, FPM, now actually supports mixed Fortran and C projects. So I'm going to be doing all of this using FPM, so we don't have to worry about all the compile commands and being able to run the code pretty easily. So what I've got listed here on the screen is the Git log for when I was putting all of this stuff together to get ready to show you, so you can see what we're going to go through. Starting at the bottom, that was just from me just running FPM new to get a new project started, and then I fixed some of the formatting, and so that's where we'll start. And then I'll show you how I evolved to demonstrate some of these features. So first thing we're just going to do is we're just going to add some C code that we call and get it to run from Fortran. Then we'll show how you can pass some arguments in an interoperable way. And then I'll demonstrate some of the additional complexities that are actually involved in passing strings between Fortran and C, because the way that Fortran and C handle strings is very different. And then I'll demonstrate a little bit of a teaser about some of the more advanced features and functionality that you can use for interoperating C and Fortran, where we can actually pass stuff through from one language to the other. So passing stuff from C to Fortran, you can do that in such a way that, like, the Fortran side doesn't even know what it's been passed, but it can then hand it back to the C, and everything's still hunky-dory. And you can almost kind of do the reverse of passing just about anything from Fortran to C, and then C can kind of see it, but it doesn't quite work that way, because the Fortran standard still says that if you want to use the bind C attribute for a procedure, all of its arguments still have to be C interoperable types, but we'll get into more of the details on that here in a little bit. So for now, let's just start by taking a look at our starting point. So our starting point, when we run FPM new, we just get a module with a single subroutine that says say hello. It says say hello. It says hello. And then the main program just calls that subroutine, so we get say hello. So if we do FPM run, that compiles, and we get hello C interop demo, right? So this is nothing special yet. This is all still Fortran, but just setting it up so that things are working. So our next step is, let's put some C code in here. Let's call some C code. And so our main program isn't going to change yet. We're still going to call say hello. But on the Fortran side, we're actually changing things. The subroutine we're going to define in the Fortran module is actually say hello Fortran. So that's not the procedure that the main program is calling. We're going to change this. We're going to say that the say hello procedure, its interface is still a subroutine that doesn't take any arguments, but we're going to say that it is bind C with the name say hello C. So that's saying on the C, in C, the name of the procedure is say hello C. And that's the procedure that should be called anytime this subroutine is called. And so what does that look like on the C side of things? So we have some C code here. We include the standard IO header. And we have that say hello procedure. So in C, there's no such thing as a subroutine. So the equivalent of a subroutine in C is just a function that returns void. It doesn't return anything. And so that's what we get here. So we have a C function that doesn't return anything, and that's equivalent to a subroutine on the Fortran side of things. and it's going to print hello from C, and then it's going to call that say hello Fortran subroutine on Fortran. And so in C they call this a prototype, so we're defining the interface to the procedure. On Fortran we're saying it's external, say hello Fortran, and on the Fortran side of things we add this bind C attribute to the procedure, saying to the compiler, don't mangle this because C is going to call it and needs to know this name. So make sure that this name is available for calling from C. And so we can go over to FPM, do FPM run, and we do in fact get hello from C and hello from Fortran. So we have a Fortran program that calls a C function that calls a calls a Fortran subroutine. So not too complicated yet, but we are now being able to run some C code in the middle of our Fortran code. So let's look at what our next step is going to be. So the next step is, let's try passing an argument. So let's check that out. Let's take a look at what that looks like. So our main program, this is where we're going to start talking about C interoperable types. So an integer in Fortran doesn't necessarily equate exactly to an integer in C, but the standard defines this ISO C binding module that is built into the language. It's an intrinsic module, and it defines a handful of types and kind parameters that are the equivalent to the C types. So if we wanted an integer that is a C int, we give it the kind C int. And so if you've got an integer if you've got an integer literal and you want to define its kind, you put an underscore and then the kind parameter. So this is an integer 42 with the kind C int. So on the Fortran side of things, we still have that say hello procedure. We're still saying that it's bind C, its interface is still bind C with the name C, say hello C. So we still got the same procedure on the C side. But now it takes this argument. And it takes an integer of kind C int, it's intent in. But this is where things get between C and Fortran have like this fundamental mismatch of. So Fortran is a pass-by reference language, and C is a pass-by value language. There are some nuances to that, and that's not strictly true in all cases, but that's kind of the gist of it, and all you really need to get out of it for this discussion. But we can tell Fortran that we do want to pass by value in this case. So we give the value attribute for this argument, and that's saying on the Fortran side of things, no, this is, in this case, do pass by value, don't pass by reference. So you have to add this value attribute when you're trying to pass C interoperable types between Fortran and C. And so we've done the same thing for this say hello Fortran subroutine. It's still got the bind C attribute, but now it's going to take an argument, and it takes this integer kind C int intent in. We have to add that value attribute again because C is going to pass this by value, so we have to expect that it gets passed by value. And so on the C side of things, we haven't really had to do much in terms of additional complexity. We add the argument. It takes an int. This procedure now takes an int argument. We're going to print it out, and then we're also going to pass it back to the Fortran side. So we have to say that yes, this is the Fortran procedure takes that int argument as well. And so now we can go back to command line and run that with FPM run. And in fact, yeah, we do still see hello from C. The answer is 42. So we passed the number 42 from a Fortran program to a C function. And that got passed correctly. Then we get hello from Fortran, the answer is 42 again. And so the C function passed that value back to a Fortran subroutine. Again, it passed that correctly. if you leave off that value attribute in either one of these places, you'll see that what actually gets passed back is not what Fortran expects. So we can try that out. So if we, for example, if we goof it up there, you'll see that what ends up happening is Fortran passes this by reference, but C expected to get it by value. So Fortran passes basically a pointer address, but C is reading that data as an integer, and so you get this random wonky randomness. And so if you're passing arguments to C like this, especially integers or whatever, simple stuff, and you're starting to get like nonsensical values, that's probably what happened is you've forgotten that value attribute there. So make sure that that's there when you're passing stuff to C. So let's look at what's the next thing we want to talk about. So now we'll talk about passing strings. So this is another one of those like just fundamental mismatches between the way Fortran handles strings and the way C handles strings. The way C handles strings is it gets a pointer to a character, and it will read in contiguous memory and assume that every next thing in memory is another character until it finds a null character. In Fortran, characters have a defined length, so it doesn't need that null character. It knows how long the string is. And so we have this kind of fundamental mismatch between the way strings are handled in C and Fortran. And so let's take a look at how we deal with that mismatch when we're trying to pass strings between C and Fortran. So let's go back to our main program. Now we're going to try and pass a string, world, to the C side of things, and it's going to print that. So how do we do this? So in the Fortran module, you'll see that what we've actually done is now we actually are calling a subroutine in this module to start with. Say hello is the subroutine in this module now, because we actually have to transform that string, right? So this is how the subroutine receives that string as an argument. It's a deferred length character. We have to transform that to something that we can pass over to the C side of things. So the say hello C procedure, its interface is that it takes a character length 1 with kind C character with assumed shape. So this is an array of single characters. This is the way that C expects to receive a string. And so we've defined this helper function here, f string to C. Basically what it does is it creates an array of single characters with a length of the original string plus 1, because we also have to remember and add that null character at the end of the string, because otherwise C won't know where the end of the string is. So that's what we're doing here, is we're creating an array of single characters with a null character at the end so that we can pass it to C correctly. And then, like I said, so C just reads until it finds a null character. So C doesn't keep track of how long a string is. So when it's going to pass it back to Fortran, in order for it to pass it back to Fortran, Fortran needs to know how long that array is going to be when it gets it. So we have to add this extra argument to our subroutine that says how long is the string that C is passing back. So we have to be explicit. So we get this extra argument of how long is that string, because we get an array of single characters. And then again, we've gone ahead and defined this little helper function that's going to turn that C string back into a Fortran string for us. So it takes that array of single characters and how long that array is and turns it back into a character with the length of just how long that array is. And just the implementation is just fill up the string. So on the C side of things, as I said, so a C string is just a pointer to a single character. And so it'll be able to print this out. And so then when we pass it back to Fortran, we have to say, we also have to tell it how long is that string. And there's a function in C from the string header, the strlen, which determines how long that string is. So it just reads characters until it finds the null character, and so it knows how many characters are there. So we can figure out how long that string is. And so now we can go back and run this, and we see we do get hello from C, world. So world was passed from the main program through that little helper function over to C, and then we get hello from Fortran world. So C passed it back to the Fortran side, back through that little helper function to print it back out. So now we can pass strings back and forth between Fortran and C. But all of the complexity that we had to add all of that extra complexity on the Fortran side of things in order to deal with the mismatch. There's actually a way we can start to migrate some of that additional complexity over to the C side of things instead. So let's go take a look at how we do that. And I will make a note here that in this instance, due to some compiler bugs, they basically haven't caught up with the most recent standard yet. I can't demonstrate this one to you quite as easily using just FPM run because gfortran hasn't caught up to the standard, and it's going to give us an error about this with the bind C attribute. And I'll talk about that here in a little bit when we get there and I try and run it. I will jump over, and at the end I'll attach a clip of me compiling this example by hand with the Intel compiler because it can handle this. But right now FPM doesn't handle compiling mixed C and Fortran code with the Intel compiler correctly, so I can't just do it as easily with the Intel compiler from FPM either. So at the end, I'll attach a brief clip of me running this example with the Intel compiler manually. But for now, I'll show you the bug that pops up. So for passing the string to C, we still have that additional complexity. We still have to turn that string into something that C is going to be able to understand properly. We have to stick that null character on the end and get that all converted correctly. But for this say hello Fortran, now what we've done is we've just said, no, this is a normal Fortran subroutine that takes a deferred length character intent in argument. We've said that it's kind C character to make sure we don't have a mismatch between the representations on C and Fortran for what a single character is. But as far as Fortran is concerned, no, you're going to give me a deferred length character. And so now we have to go over to the C side of things and demonstrate, well, how does that work from the C side of things? So the Fortran standard says that for a C companion processor, so a C compiler that goes with a Fortran compiler so that they can interop, in order for it to be standards conforming to the Fortran standard, it has to define this new header, which defines this type and a handful of other things and some macros and stuff like that to help define these types that can then be passed to Fortran as though they are Fortran objects. So the say hello C function is still just taking the regular old C string because we still did that properly on the Fortran side of things. But now in order to pass this back to Fortran as a deferred length character, we need one of these CFI C descriptor types. And we can create one of those with the CFI establish function. And so what that takes is a pointer to the descriptor object that you want it to populate. And so we add that ampersand to give it the reference So we give it the pointer to that variable. The thing you want to fill it up with. So in this case, we want to give it the string that we wanted to populate because we want to populate this like a Fortran string. CFI attribute. This will be either pointer, allocatable, or other. And since on the Fortran side it's not a pointer and it's not allocatable, that makes it other. And then the type of thing we're creating. So in this case, a CFI type character. So because we're creating a Fortran character. It needs to know how big is it, so the length of the string in this case. It needs to know its rank. So in Fortran, arrays have rank. So a rank 1 array is just an array with a single dimension. Rank 2 has 2 dimensions, etc. So rank 0 means it's a scalar. It's not an array. And then this null is a pointer to some other stuff if you're doing some more complicated things. In this case, we just pass null because it's not going to look at it. And so that populates this name descriptor variable with what is now effectively a Fortran character. And that function returns an error code, so you should check to make sure that that function did in fact succeed. In this case, it does, but you should, just to be safe, check it anyway. And then we can pass, again, a pointer to that descriptor type. So we put the ampersand there in front of it again to get the pointer to it. We pass that to Fortran. And so what will happen is C has this fancy object, this fancy object, but on the Fortran side of things, it just is going to see it as a character, a regular old character variable. So this function is going to fill up the address space of this variable with what is exactly what the Fortran character type looks like. And as I said, Fortran says that character argument name at 1 must be length 1 because procedures say hello Fortran is bind C. So what this is saying is that in order for this to be bind C, we're supposed to only be able to pass characters with bind C this way, where the characters are length equal 1 and we have an array of them. But as of the latest standard, with the additions for this new descriptor type, this is actually valid now. So basically, it's just Fortran hasn't caught up with the standard yet. But this is the proper way to do it. And as I said, at the end of the video, I'll add a clip of me demonstrating manually compiling this by hand with the Intel compiler and running it. But for now, we'll go ahead and move on. As I mentioned in that one example where there was a Fortran bug that wouldn't let me demonstrate it, I checked out that same code, and as you can see, I can manually compile it with the Intel compiler. So we've got iFort compiling that source code that Fortran was choking on, so it can compile that, and then we use the ICC compiler to compile the C code, iFort to compile the main program, link it all together into an executable, and run that executable, and we can, in fact, use that more complex way of passing the C strings to Fortran in a way that Fortran just thinks it just receives a regular Fortran string, where we had this CFI C descriptor type here, and the Fortran side just receives it as a deferred length character. So that's just a demonstration that there is at least one compiler that can use it this way, and that it does in fact work. But for now, we'll go ahead and move on. So now let's talk about passing stuff from C through Fortran as though, so on the Fortran side, it's going to be just a black box. We're just going to hand something, we're going to pass an argument from C to Fortran, and as far as Fortran is concerned, it's just a black box. So we're completely doing away with the original like calling sequence and procedures that we had. We're going to call beginning from the main program. And so in the module, we're defining the interfaces. So the beginning and ending are going to be on the C side of things. So we're defining the interfaces to those. Beginning is just doesn't take any arguments. The ending is going to pass back a C pointer. So a pointer in C is just a memory address. And so that's all that Fortran is going to know. C gave me a memory address. It's a pointer, but that's all it knows. If you want to get into more advanced stuff, there are some additional functions that you can call if you do actually know the types of things, and you can start to get access to what's in a C pointer. But for this simple use case and just demonstration purposes, we're not going to get into that more advanced stuff. As far as we're concerned for now, this is just a C pointer, and we don't know anything else about it. But our middle procedure here that's written in Fortran, it can accept as argument a C pointer, and then it can pass it back to the C side of things. So in C, it's saying, so the beginning function doesn't take any arguments. It's going to define this character, a C string, which is a pointer. Right? That star there means it's a pointer. So we're going to create this string, and then we're going to pass it to Fortran. So the interface we write on the C side of things says, well, yeah, this procedure takes a pointer to a character, so it takes a C string. On the Fortran side of things, it just sees this as a C pointer. And then the ending procedure, again, it takes a C string, a pointer to a character, but on the Fortran side of things, as far as it's concerned, it's a pointer, so we're just going to hand you that pointer back. And this is now the good time to discuss interface matching between the C and Fortran side of things. The compilers can't help you with this. The C compiler doesn't know about Fortran and doesn't look at the Fortran code when it's compiling the C. So it does not know when you tell it, hey, this is the interface to that Fortran procedure. It doesn't necessarily know that it is in Fortran. It might just be in C. Could be in any other language. But it's going to believe you when you tell it that this is the interface. So if it doesn't match on the Fortran side of things, so if the Fortran procedure doesn't actually have this interface, you won't know. Same thing on the Fortran side of things. The Fortran compiler doesn't really know about C. I mean, it does now because of the interoperability functionality, but only in a limited sense. When the Fortran compiler is compiling this code, it's not going to look at the C code to check. It's going to believe you that this is the interface to that C code. If they don't match, it's not going to know about it. It's not going to tell you. So in this instance, they don't strictly match, but they effectively match, right? On the Fortran side of things, it's saying, hey, these are pointers. These are C pointers. That's on the C side of things, they are pointers, but on the C side of things, we're specifying what kind of pointer. It's a pointer to what? So on the Fortran side, it doesn't know that, but on the C side, we do. And so this is the tricky part about dealing with interoperating between Fortran and C is these interfaces are very important. You have to double check that these match on either side, because if they don't, then things won't work and you'll be chasing down weird bugs and the compiler's not going to tell you about it. But on the C side of things, so we're saying, hey, we know we created a character here and the Fortran side is going to pass it back to us. So we get a C string back and we can run this code. So Fortran called a C function. The C function created a string, passed it to Fortran. Fortran passed it back to C, and we can print it out. Right? So we create create a string over here, pass it through some Fortran code, and get it back, and we can print it out. So that's all working. So basically, you can treat the C side of things kind of as a black box. So you can interface Fortran to some C library when that C library is going to pass something to Fortran. Return, you're probably going to call some C function to create some object in C, some structure, whatever C is going to pass back to the Fortran side of things. You can basically just treat that as a black box, and then you can write some little interface procedures over here that take that pointer back and will return something that is interoperable with Fortran, an integer, a real, a string, whatever. So you can interface with a more complicated C library and basically treat a lot of its data structures as just kind of black boxes. We can also, in some sense, do the same thing on the Fortran side of things, where we can pass stuff to C, and C will still kind of treat that as a black box. So let's take a look at what that looks like. So now on the C side of things, the C is going to be this middle procedure of like we're going to start in a Fortran procedure, it's going to call C, but C is going to pass that thing back to Fortran. And so on the C side of things, we get these CFI C descriptor pointers, right? So in theory, there's some more advanced stuff you can do, and these are interoperable in the sense that like you can figure out what these are from the C side of things and actually mess around with them. For this example, we can just treat it as a black box. So the middle procedure takes a pointer to one of these C descriptors, and the procedure it's going to call just takes that as its argument. On the Fortran side of things, it's not quite as straightforward as that. So in order to put these bind C attributes here, these arguments do have to be C interoperable types, which means we can't just toss any old thing from Fortran to C the way that we could do the reverse, but it does give you a lot of leeway. So if you've got data structures that you do want to pass through, you can define those derived types as bind C, and then those are applicable here. You can pass those through C as a black box, but for this simple example, we're just going to use an integer. And so in this instance, so that middle procedure, the thing we're going to call C from Fortran, its interface. Now we don't have to put this value attribute here, because as far as C is concerned, it is getting something from Fortran. It's a Fortran thing, and then it can pass it back. So now we no longer need this value attribute here to pass an integer around. So we're going to create an integer, pass it to C, and C is going to pass it back to us, and we're going to print it out. And the answer is 42. So now we can pass this integer to C without that value attribute and get it back. There is a lot more that can be done. You can define structs in C and matching derived types in Fortran with the bind C attribute, and they can actually be interoperable. And you can use this CFI C descriptor type to actually create objects on the C side. You can create C structs on the C side, wrap them up into one of these descriptor types in such a way that when you pass it to Fortran thinks it's the derived type that's defined with the bind C attribute, and it can just work with it directly. There are more advanced things that you can do, and you can actually make these kind of things really actually talk to each other and work together. But that's some more advanced stuff, and I don't have time to get into it in this video. So if you're interested, you can go and read more about it in the standard and go Google around and find some more interesting examples of things you can do with this. But that is, for all intents and purposes, the basics of how you can get started with getting Fortran and C to talk to each other. So I hope you found that exercise useful and informative. If there's other stuff you want me to demonstrate about Fortran, let me know in the comments. Don't forget to hit that like, subscribe, notification button to make sure you're getting new videos when I put them out.